Hello and welcome to the Comparesoft Maintenance Podcast. In this episode, we're looking at condition monitoring, the essential hardware, the key software requirements, and the reasons why so many programs fail to deliver, even when the right tools and data are in place. Today, I'm joined by Andy Mellor, a condition monitoring and reliability specialist with over 20 years of experience, including 8 years as a research and plant performance engineer at British Steel. Andy now runs Pragmatic Maintenance and Reliability, where he helps organisations proactively identify machinery faults. We'll explore the root causes for predictive maintenance failures, the simple wins most maintenance teams overlook, and what it takes to turn good engineering data into action at the management level. Andy, it's great to have you on the podcast. How are you?
I'm very well, thank you. Thank you. Thank you for having me. Thank you for giving me this opportunity.
Yes, it's a pleasure to talk to you. So, Andy, I'm going to jump straight into it. One of your first experiences of condition monitoring programs came at British Steel, where you worked as a research and plant performance engineer. I'm curious, what did that hands-on operational experience teach you most about why machinery problems keep repeating?
It's interesting. British Steel were a keen adopter of approaches and methods like total quality management and statistical process control. And these bore fruit in terms of optimizing processes and productions. However, it took some time to translate those disciplines effectively into mechanical maintenance and reliability management, particularly of rotating machinery. So, as a lot of people experienced, many of the issues we were faced were due to, for example, a lack of follow-through with installation standards. But that was underpinned by a culture where maintenance and production were divided, and no one was really measuring long-term reliability. Of course, if you don't measure something, it doesn't improve.
Yeah.
One story, if I can tell a story,
Yes,
one
go for
story
it,
in
Andy.
particular, one story in particular sticks in mind. We had basic oxygen steel vessel hood cooling pumps. So obviously the Boss vessels are critical equipment for producing steel from iron. There were 9 identical pumps between 3 vessels. These were sort of between bearing centrifugal pumps. They had 2 duty and a standby pump on each vessel. So there were a series of failures, and I was asked to follow up on that as a plant performance engineer. As you dug into the background story of what led up to these failures, they'd had the pumps overhauled, and shortly after the overhaul, they had a motor burnout. And then they went in and checked all the motor protection settings and found that some of the settings were wrong. But when they put the settings right, they couldn't get the pumps to run.
Okay.
So they then started gagging in discharge valves to reduce the flow rate and get the amps down, and they could run the pump successfully. Several months went by, and then they started having bearing failures, particularly with motor drive end bearings and the pump drive end bearings. And this was the point that I got asked to go down with vibration monitoring equipment. So we checked all the pumps, and we found a number of faults, from misalignment to sort of coupling wear to early stage bearing defects and some motor soft foot. But the overwhelming vibration signature was blade pass frequency. And we actually decided to measure vibration on the stationary pumps and found that in some cases vibration levels on the stationary pumps were higher than on the running pumps. Following up this, investigating this blade pass frequency, we discovered this prior history, and it seems that in order to cut costs compared to sending the pumps away for an OEM service, they'd bought a brand new pump as a spare and provided it to an external repair shop and said, this is what you get all the dimensions off this. So the repair shop had overhauled the pumps without realising the impellers needed to be cut down to match the flow rate we needed.
Right.
So no surprise that the motors burned out.
That effort of trying to save a bit of money has actually caused them more harm in the long term.
In the long term, yes. Yeah. And then the high vibrations were obviously the result of the full-size impeller working against your partially gagged discharge valve. The the bearings were suffering on the standby pumps were suffering as a result of false Sprinelling. because of the high vibrations, and the motor drive end bearings showed a preference for failure because they were roller bearings, which we know are more susceptible to false Spinelling than ball bearings are. So the real tragedy here was that in an organisation under considerable financial and existential pressure, I mean, the works is closed now, the response to these discoveries was more political and finger pointing rather than, okay, let's get together, guys, and search for, let's improve our processes and systems.
Yeah. How frustrating was that for you as an engineer there?
Oh, I've always, I mean, I wasn't, a colleague of mine was physically threatened. I was never physically threatened, but there was like, get your vibration analyzer out of my pump house because you're causing me problems. I'm here to help you stop having problems. The whole works wasn't like that. There were some areas that were better than others, but it's incredibly frustrating because all you want to do is do a good job and not really deal with the politics, but inevitably you always have to deal with some politics.
Yeah, and just like staying on that frustration, that was a big motivation for you for starting your own consultancy, Pragmatic Maintenance and Reliability. It came from, making sound recommendations and not seeing them acted upon. So could you walk us through that turning point and why it sort of pushed you into starting your own service?
Yes, I'll have to tell another story.
Excellent.
We're now several years on. I've left British Steel and I was working for AV Technology, which I loved when I started there. And I was asked to run a contract at Anglesey Aluminium, the smelter at Holyhead. I'd set up a condition monitoring program there and had been running it for a couple of years. I think part of the reason for that choice was the metals industry background and also partly because I had relatives in Anglesey. So I was brought into the site at a central level. The plant was divided up into 3 different areas: pot lines, carbon, which made anodes, and smelt and the casting shop. Some maintenance managers showed more responsiveness to reports and getting things done than others. But at the time, the carbon plant was particularly reluctant to action things. And we'd had a number of failures of equipment that had been predicted, and then, no action had taken, and they'd failed in service. In one case, if a piece of equipment failed, like the day before it was supposed to be taken out of service. Now, aluminium smelting, if you've never been involved in it, or for the listeners, I can tell you it's a filthy process. Everything is, you've got anode manufacture, and because they use about 250 to 260 anodes a day. So they had to make that many every day. So the anodes are made from ground petroleum coke and pitch, and the alumina is a white powder. So everything's covered in either black powder or white powder, or grey in the middle. And not the nicest of conditions to go out and collect data for 2 weeks a month when you're away from your wife and family, living out of a suitcase. So partway through one measurement routine, I found in the worst part of the whole site, which was called butt crushing, where they crushed the residual material off the anodes to recycle it. I discovered literally a crack in a motor case with very excessive vibration. This was driving a throw conveyor. And I'd been reporting this motor as having high vibration and asking for something to be done about it for several months, and now it was on a pathway to destruction. So you start to question why you're bothering. So we might say that we had a frank discussion with the maintenance planner, who was very patient, listening to me rant at him. And the outcome of that discussion was a surprising fact. More surprising to me came to light that the maintenance teams were motivated through their pay structure for PM conformance, in other words, completing the scheduled preventative maintenance inspections, to the result that any corrective work took a backseat, and any actions resulting from those condition monitoring findings or from PM inspections went onto a backlog. But there frequently wasn't enough time on a down day to do all the PM inspections and address the backlog. So the backlog grew.
The PM inspections took priority.
PM inspections took priority, yes. Well, but because they were, and if you were in that situation, obviously they would, because you were that's what you were paid on.
Yeah.
So the planner and I went to my contract focal point, and the three of us, with support, took this issue to the works director. Put a case together and presented our evidence. And within a year, they transitioned to a different maintenance structure with dedicated reliability teams focusing on long-term reliability of the assets, and a pay structure that incentivised reliability and reliability improvement, and not PM conformance. So, needless to say, the reliability and maintenance cost effectiveness on the site improved. And I think I wasn't the only person by any means who was frustrated by this. I worked with a lot of good people. I wouldn't say it was down to me. Maybe I was a catalyst or something, but that experience came around the same time that I was, and I think probably helped me argue the case with my then boss at ABT that I should be studying maintenance asset management, and that's how I got on the master's degree at Manchester University in maintenance engineering and asset management, which excellent course. And completing that led me to start Pragmatic. I got the course prize. I had really struggled at university as an undergraduate. I now know that is due to undiagnosed ADHD, but I didn't know I didn't know why I struggled at the time. But that had knocked my confidence. A master's degree, I excelled at, and that gave me a lot of confidence, and that gave me the confidence to start Pragmatic.
Excellent. And this has been running now for over 14 years. Yes,
14 years, and we're still here. I've not managed to bankrupt us yet.
Oh, excellent. If I just go back a bit there, Andy, you said about presenting your vibration analysis to one of your plant managers there, floor managers, and you were presenting it for months. How were you presenting it? What tools were you using, and were you taking data to him that was showing this vibration?
Yeah, we started off producing throughout this period, reports evolved, and one of the managers in particular at Anglesey Aluminium was quite engaged. So he had ideas about how he wanted the data, reports presented, and that influenced my thinking. So we ended up with a sort of an amalgam of what. And it's evolved since, on another site where we use the same reporting template, which we call an action note. We had a client that overhauled the wrong conveyor. There were two adjacent conveyors with very similar tag numbers, and the repair team overhauled the other conveyor.
Oh, okay.
And so the action notes evolved again to include a photograph of the asset.
Okay, yeah.
It's yes. So I think you need very clear asset identification. You need a concise. I mean, maintenance managers are busy people, so you need a concise summary of the problem. You need fairly visible indicator of the severity of the state of your opinion of the severity of the status. They will make their own evaluation. So we color that's color and shape coded. So a concise summary of what you think the problem is, a concise summary of what the data is that leads you to that conclusion, with then a deeper dive for people who have got the time and who want to go into that, and a concise summary in plain English. I think it's important this is all in plain English. In plain English of what your recommendations are, and those recommendations should be for actionable, an actionable maintenance job that somebody can complete. And I think it's perfectly acceptable not to know. As a condition monitoring engineer, you won't know everything about the asset and about the possibilities. So at that point, I think it's important to have conversations. So I would go to I would go to a maintenance engineer and say, look, I've got some concerns about this. Here's my data. Here's my report. Before I submit this, what are your options for overhaul? What are your and that and that can have some very productive consequences, and it helps. Particularly acting on condition monitoring findings is all about building trust. The engineer must trust that there is going to be an outcome out of this that's beneficial to them, and beneficial to the reliability of the asset. So I think you've got to you've got to show that you're willing to explore those aspects of the problem. So to give you an example, we had a HV motor driving a ball mill. We suspected a fault with the drive end bearing of the HV motor, which I suspected was a cage issue. Cage problems don't tend to trend very well, unlike raceway problems and bearings.
But when you say suspected, were you looking at data, or was this like something that you picked up from experience?
No, you're looking at data. You're seeing in a demodulated envelope reading, you're seeing cage frequency there. You're seeing evidence of rubbing, what we call a haystack at higher frequencies in the vibration spectrum. So the number of indicators that make you think, okay, that's a lubrication issue and it's associated with the cage. My experience tells me that these don't tend to, the vibration levels don't tend to increase towards failure, and that the strength of the signal that you get is dependent on the strength of the rubbing that's taking place. And if there isn't much material left, the signal can actually decrease. So you don't tend to get a very clear picture of how much residual life you've got. And this is a critical machine, So my opening question was, well, if this motor were to fail tomorrow, what would you do? And because I think it's got a problem, and I think you should think about how you might address a potential breakdown. So going out and having a look at the motor together, there's no runway beam. I mean, it's a big HV motor. It's going to need to be lifted out. There's no runway beam in place to lift it out. The spare motor we found in an unheated store. It had been there for several years. Nobody turned the shaft. Bearing, winding condition questionable. So the maintenance team put a plan together. They got the windings baked. They ordered new bearings. They changed the bearings on the spare. They moved it to a better location. They put in a runway beam above the existing motor. There was a shutdown coming up. It didn't make the shutdown. It failed a couple of weeks before the shutdown, but because the work packs had already, they'd worked on the work packs for the shutdown for replacing the motor, because the spare had been overhauled, the runway beam had been fabricated, inspected, and certified and put in place. So compared to a surprise failure, the benefits of finding the problem, and anticipating it were quite significant, even though it actually failed in service. So I don't think condition monitoring is always about. You can't always be certain when things are going to fail. If I could put, if my prognostics were as accurate as my diagnostics, I would be. I'd have probably retired by now. That's the $1 million question: is how long is this going to last?
Yeah,
and you can't always answer that question, and you shouldn't pretend that you can.
And how would you? If you could, how would you define a successful condition monitoring program today? And have you seen that definition of success change over the last 10 years with these introduction of new tools?
No, I don't think the definition has changed. I mean, the definition is primarily a financial one, and is it impacting on the bottom line, and is it providing benefits in terms of improved reliability, reduced downtime, reduced maintenance costs, etc. I don't think those criteria have really changed. Are those criteria always measured properly? No. Really successful programs will have a return of better than 5 in 1. I've seen 10 to 1. Nice. But to get there, you need to integrate condition monitoring with other reliability disciplines. You don't get there from just doing condition monitoring on its own. It's part of a wider effort.
Yeah. So when you're called to a site that's, they're struggling with their unplanned machinery downtime, what do you diagnose first? I'm really interested to understand your process when you first step in.
Ooh, right. Well, I think first of all, action without diagnosis, I think, is problematic. So that's the first thing I would do is I would try and do a couple of Paretos. One would be, or something, or if not a Pareto, something like a rash map, where I would map out the problems try and understand the process and map out the problems onto the process. So, which assets are the main contributors to downtime, and or to maintenance man hours, or whatever the constraints are. Constraints are important. What are the constraints? Is it a production constraint? Is it an availability of getting at Anglesey Aluminium, the constraint was it getting enough man hours away from PMs to do the work. That was the constraint. So I think identifying, with my maintenance management hat on, it's identifying what the constraints are in terms of resources, and identifying what the bad actors are on the plant that are contributing to downtime or poor product quality or scrappage, or or whatever the issues are, because those issues vary widely from industry to industry, and even from site to site within the same industry. So that I can't really answer that question without some specific context, if you like, of a site. So I think if you're asking my process, understanding the context is the first part of the process.
You're mapping out those critical assets to start with, yeah.
Very much so, yes. Yeah. Yes. Well, the critical assets and the bad actors, because they're not necessarily the same. And then the other thing is that I would try and run a Pareto on what the failure or fault categories are that relate to maintenance processes. So, are things failing as a result of poor installation? Are they failing as a result of overload? Are they failing as a result of poor lubrication? What are the main issues, and what does that tell us about how we can look at the functions that the maintenance team is doing, and maybe improve those. So going back to Anglesey Aluminium, there was an investment made in laser alignment equipment because we found that a lot of mechanical issues were related to poor installation.
Okay.
So there was some training there.
Yeah. Once you find those bad actors, them common pain points, it's quite simple to put down. So this is what we need to install.
One of our current customers, we'd run a program for several years, and then they said, "Well, you're finding so many lubrication issues that we'd like you to take on the lubrication. So,
yeah. It sounds quite simple when you say it like that, Andy, but I guarantee it's not.
well, what makes it less simple is politics and and a blame culture. I think one needs to get away from a blame culture in particular. Production want the plant to run. Maintenance doesn't get paid ultimately. No one's going to get paid unless the plant's producing what it's supposed to produce. We're all in it together, really. And if you're a contractor, generally like myself, and then I think that as far as possible, my role is to support support maintenance and get embedded in and to the more embedded you are, the more they feel you're part of their team and on their side, the better.
Yeah. And you've pointed out to me that the simple things like fitting oil sampling valves are, sort of no-brainer for greater maintenance control. What other simple, quick wins do maintenance teams often overlook, in your opinion?
I think two things I'm going to point out here. One is visual inspections. Just you have gauges, telltales, what have you. Make it obvious to people what an acceptable range is, even if it's just putting a green piece of paint on the rim of the gauge. Where you expect the needle to sit. Make it obvious for people who are doing rounds or inspection routines what working normally is. So that's kind of one very simple thing, and it's almost free. And you take to extend from that, take time in putting walk rounds together, take time in putting, have visual standards. You can use. I don't know whether buying a cheap thermal imaging camera counts as that counts as cheap these days. I mean, the price has come down so much, but you can do so much with a thermal imaging camera that costs a few £100 that we would have thought was extremely impressive back in the 1980s when we were pouring liquid nitrogen from a Dewar flask to cool the detector. The picture quality of a camera you can get for a few £100 is so much better than what we had in the 1980s, and the unit cost £30,000. So those could be seen as quick wins, but you do need to. I think you do need to train people and make sure they understand what the limitations of them are. So I think maybe and another potential question was, what are the common reasons programs fail to deliver? They're generally cultural. It's not down to the tools and equipment that are used. It's generally down to culture and investment in training. And not only the people who are taking the data, but crucially, people like the maintenance planners who are responsible for turning recommendations into action. They need to have realistic expectations of what can be delivered and what can't be delivered through condition monitoring, and really you can't overstate the importance of frequent and clear communication there, and getting feedback on the work that's been done, so the person doing the diagnostics understands what has been done and what has been found.
It's interesting. So if you step into a site and you understand that, okay, the culture isn't there for condition monitoring, would that be the first real actionable step they have to take? Then they have to build that culture. They have to train the engineers in that thinking.
Generally, yeah. The short answer, yes. But generally, you will, particularly if you've been invited in, you'll find that there's somebody you can work with.
Yeah.
So you work with them, and you say to the other people, I respect your right to be skeptical. Never make it an ego fight. It's just that's not going to work. I did when I was at ABT, I took over a site from a colleague who was overworked, and they'd had at the same time as I took the site over, they'd had a new maintenance manager who initially was very hostile. He'd had a negative experience of condition monitoring at a previous workplace. So his opening gambit to me was, I don't think you'll be around here for very long because I'm not a believer in condition monitoring, and I'm going to get rid of the. I'm
see that as
temporary
challenge
at the moment.
accepted.
Yeah, very much so. Yes. Yeah. Oh, really? Well, So I said to him, and this is before Pragmatic. I said to him, okay, I'm not going to argue about your previous experience. Your experience is your experience. Have you got an open mind? Are you willing to, if I can show you how it works and that it does work, are you willing to change your mind on that? We've got, 3 months before you're made permanent. We've got 3 months to run on the contract. If in the next 3 months we can show you a benefit, are you open for that? Yeah, okay. This guy eventually was one of my strongest supporters. We found a problem on a fan, and the pedestal was resonant, and the bearings were loose, and so I explained what I thought the problem was. I said, we looking back in historical data, we've seen this before. You can cure this by stiffening this pedestal. Let's have a look at how it's held down, and as we brushed off the soap, it was a soap powder factory. As we brushed off the soap from that was crusted around the bottom of the pedestal, the pedestal had cracked through the foot bolts, and the two cracks had passed each other. So the whole thing was being held by a little strip of metal. Wow. And the look on his face. And he went, right, okay, and they welded it up, and I didn't tell him that I'd actually seen a little bead of weld poking out of this soap. I'd seen it was cracked, it had been cracked before, and I thought, okay, I know what's happening here. And we stiffened it up and welded some angles onto it, and it ran for years after that, because
wow.
we'd solved the root cause of the problem,
Yeah.
And I think that's where the long-term wins. We talked previously about returns on condition monitoring and what makes a good program. What makes a good program is where you do attack those root causes, where it's nice to find failures, and it's nice to anticipate them before they cause downtime. But if you've seen evidence of repeated failures, you should then be going into attack mode, and you should be trying to eliminate those repeat causes of failures. On the same site, we found a motor bearing that had been damaged by electrical discharge. A bit of digging, it turned out that there should have been an insulated bearing. It wasn't an insulated bearing. And looking at the maintenance records, it seemed the original overhaul, 10 years after this motor was first bought, the original overhaul, they changed the bearings, and it had gone every 2 years after that. So the suspicion was that on its first overhaul, it didn't get insulated bearings in. So yeah, just some examples of using the data, and it's why feedback is so important, because if you don't get the feedback, you don't get the opportunity to do those those eliminations of the root causes.
Yeah. And you touched on there the importance of being able to report on data and findings. So if a maintenance leader was in the market for a condition monitoring tool or a system today, what are the capabilities that actually matter most? Like what requirements or features should they be prioritizing?
That's a good question. Yeah, that's a good question. I'm a big the equipment that I use nowadays. You'll find most quality data collectors have got a 24-bit A to D converter. and are capable of using a triaxial sensor, and that makes so much of a difference in data collection time.
Mm-hmm.
Not that the aim is to go around and get the data as rapidly as possible. I think the aim is to get a report out that is accurate as efficiently as possible. But the accuracy is more important, I think, than the efficiency. But having having a good quality low noise A to D converter and signal processing chain means that you can collect accurate data rapidly, and therefore that your time that you're charging your client for, or the time that if you're running an in-house program, the time that you're getting your guys to spend on the data collection, that is that's the output of that is maximized. And then you can spend more time on the follow-up and those deep dives and the digging into root causes, and that can be part of your standard offering. So I think a good quality A to D converter and a triaxial accelerometer, so you're getting your 3 axes of vibration axes in one hit. That's tend to what I go for. In terms of a thermal imaging camera, I'm making sure I've got the right range, temperature range, and the right number of pixels for the accuracy that I need. For most of what I do, which is mechanical, electrical, and process, I don't need a really high number of pixels.
Mm-hmm.
I can quite happily get by with a mid-range camera. So yeah, I think it's, and then I think the software. What analysis capabilities does the software have? Is the software easy to use? Is it easy to set up? And is it easy to? Does it offer you features which you can screen the data with effectively? Because if you're going to collect a lot of data, you don't want to be looking at it all. You better have some process in place that you can effectively screen out the remarkable from the mundane.
It's okay collecting so much data, but if you're not going to use it, you're not going to present it as you need to, nothing's going to be done correctly.
Well, yeah, indeed, and having the right. I mean, compared to when I started, things have just come on so much. But I think we already got to the point probably about 10 or 12 years ago where things were good enough. Wow. I'm still using a multi-channel data logger for my, I also do sort of troubleshooting acceptance testing on large rotating machines where they might have proximity probes and you're plugging, multiple channels into a panel. And the equipment I use for that is still runs on laptops, with Windows XP, and it does everything that I need to do for the job. Yeah. So I think we've got to a point where the hardware has already evolved as much as it needs to evolve.
Yeah. If we go back to just touching on your past frustrations again of how you're making these recommendations in previous roles and not seeing them acted upon, I'm really interested to know how best should an engineer present, their vibration thermology or oil analysis findings to their superiors, to a plant manager?
Well, as I said previously, you're dealing with busy people, so you better highlight what you think is the significance of the problem. So you start off by saying, I found an issue and I think it's I think it deserves your attention. This is what I think the problem is. This is what I think the potential consequences of the problem are. Here is my analysis of the causes of this issue and what should be done with it. And here is your option. I had a manager in British Steel who said, "Always give me an option." What's my do nothing option? Well, you can leave that in the service. Maybe for business, the business requires it. to be left in service, and that might be acceptable if it's not going to propose a danger to somebody. So this could be how you resolve the problem. This could be how you mitigate it and extend it. And going back to one of my previous answers when I said it's important to have the conversation about when could you maintain this? What are your options for for doing this work? Because if you have those conversations, those we don't have an option for doing this work at the moment because we don't have a spare and it's obsolete. So we're going to have a project. Well, okay, in that case, you better A, expedite that project, and B, to identify what the replacement is, and B, we better take action to minimise the wear rate from here on.
Yeah.
So, I think I think you've got to, however you present your information, you've got to show to your audience that you understand the context of that information, or if you don't understand the context of that information, you ask for the context of that information so that you can provide some guidance about how to interpret the information you're giving in the light of that context. Because at the end of the day, we're not trying to have the best machinery in the world in our machine pool. We're trying to make a product at a profit, or provide a service at a profit, or complete a mission if we're in the military, and have the equipment in a service ready state. So, the maintenance of the equipment is not the goal of the organisation.
Yeah. Would you say an engineer is going to be more successful in presenting their findings by saying, look, this is the business consequence if you don't act upon this fault? Yeah.
Yes.
You've mentioned earlier it's political, it's financial. If they come with that information instead of just proving that there is a fault.
Very much so.
Yeah.
And then you're taken more seriously. If you can demonstrate that you've thought through the consequences, or if you don't know the consequences, that you're willing to ask and explore those consequences, then you're going to have a more productive conversation. Because what do people do with bad news? There are two things. One is that they can have a tendency to deny it. That can't be true because the consequences are bad. The fallacy of bad consequences. And the second thing is that the potential error they catastrophize. The sky's falling down. Well, neither may be true. There is an issue. What we need to do is to work together to get to understand what the severity of that issue is, what the potential consequences are, and therefore to make good, a better decision on that. And that you're, as a condition monitoring engineer, you might not know all that. As the maintenance engineer, you might know all that, but together you probably you can probably come to that picture. So this is why I said before, it's great if you can become embedded in an organisation as a partner.
So Andy, we like to save these last questions here for sharing your insights and advice for the listeners. So if a plant manager suspects their condition monitoring program is sort of drifting, they're not seeing the desired ROI, what should they do in the next 30 days to correct that?
Audit. Conduct an audit. So there are several audit tools out there that can be used, and I think if you Google, you'll probably find one, or get an experienced professional in to conduct an audit. Because why is your program drifting? Well, until you've had that audit, you may not know. There could be you could be not getting the feedback. You might be not making the right calls. You could be and missing problems, and that might be due to the way that you're set up. You until you know why that predictive maintenance program is drifting. So audit. That there are there are tools, or get an outside pair of eyes in.
And as more sites adopt AI, remote sensors, automated diagnostic tools, how important is it to keep that human in the loop, if you say, balance that technology with the judgment of experience of trained technicians and engineers?
Oh, I mean, this is a real problem because the experience base is declining.
Mm.
Due to age and demographics. We all know AI is as good as its training set. I think I'm very optimistic about AI. I think its adoption in diagnosis and maintenance is going to be a good thing that will provide benefits. But I think right now it's very good at screening. You can use it to screen a lot of data quickly and in a consistent manner. It has much more consistent judgments than a human being. And if you're interested in the work on human judgment, go and have a look at Daniel Kahneman's later work. He's done quite a lot on the consistency of judgment. So I see a role for experienced personnel in validating the output and follow up checks and inspections and tests. So the first question before we're going to commit maintenance resources and potentially take a multi-1,000-pound piece of equipment out of service is how confident are we?
Yeah.
So I think there's a role for the human being in validating that confidence level. And I think there's also a really important role in feeding back information so that AI improves its diagnosis over time. Because if it continually gets recommendations wrong, people are just going to start to ignore it, and it's going to be a wasted investment. So I think it's important to not to just have that initial training period, but to continually feed data back and update that training. Obviously, an AI system connected to a number of sensors only gets information from those sensors. It might output a recommendation, but all those other things that I've talked about, all those discussions, it can't have those discussions. Those discussions need to happen, with someone else. And then it may be a role for a person to advocate on behalf of the AI to sort of go, right, well, looking at the condition monitoring data, these are the implications, and these are the what ifs from a progression of failure side of things. And then the other thing that I think people need to think about in terms of AI is, we know from experience that industrial reliability improvement and consistent, reliable operation has been about adopting a proactive mindset, a proactive culture, systems and processes that produce good and consistent results. If we're now saying we're going to let AI make a load of decisions, are we just allowing ourselves to get into a situation where we've just got more to react to? So you don't want to throw out that culture, those systems and processes that go with reliable operation and an improving reliability picture and that proactive mindset to go to something that's just giving you more to react to. So, there are skills and knowledge there that can't be immediately replaced by AI. So I think it's a potential trap to fall into if a management sees that as AI as a way of de-skilling and downsizing maintenance teams, because you could just end up pushing them back into a reactive culture.
Yeah. And if you could leave listeners with 3 key principles that prevent machinery from needing emergency troubleshooting, in the first place, what would they be?
This is going to be really boring, and I'm going to leave you with. I'm going to break the rules. I'm going to leave you with 4, and you can't stop me.
A bonus, lovely.
Yes, a bonus one, and it's what it's always been. It always has been, making sure that your machinery is properly specified, properly installed, properly maintained, and properly operated. If we do those 4 things, it'll be reliable.
Andy, well, you've been an excellent guest. You've shared some really practical insight of what makes condition monitoring programs work, from the simple wins on the plant floor all the way through to getting buy-in at management level. And I think that's something anyone in a maintenance role can take away and use today. So thank you so much for joining us, Andy.
You're more than welcome. It's been a pleasure being on. It's been nice to enthuse about condition monitoring and maintenance for an hour.
Excellent. And thank you all for listening, and we'll see you on the next episode.